All right, welcome everybody. This is our weekly lifecycle provisioning and technical work group in OPI. Last week, we dedicated this time slot for API work group, so we didn't meet for 2 weeks already. So it's a good opportunity for us to kind of meet and see the direction, the gaps, the open questions and stuff like that. So let me start as usual with a recap. So this work group is focusing on these 5 major things: the discovery and provisioning of DPUs and IPUs, the inventory information, the boot sequencing between the host and the DPU, lifecycle and updates, monitoring and telemetry. And today I want to focus on several open pull requests that we have outstanding without any reviews, so I'd like to focus on that and to show you a few more progress things that we made during the past 2 weeks, so everybody is up to speed. Are there any topics from the team that you want to raise or specifically talk about today? Let me pause for a second just to hear people raising topics of interest. Okay, no topics, so we'll continue with the agenda. Okay, so first I see Andre here on the call. Andre raised this pull request to add a new diagram. So Andre, if you can walk us through this, what the difference I think this is.
Yeah, Boris, I saw your comment, but unfortunately I had no time to update and provide more description. So I think it's a continuation of our discussion we had, 3 weeks now ago, when we said that we will add a diagram with BMC, which is part of IPU. So I think on other, if we look at the original page, we have the 3 diagrams, and on all diagrams, our BMC is completely separate. It's either, I don't know, like a mezzanine card or a separate chip on system, which is connected to GPU or XPU with different interfaces. What we did with Match, and we worked on this diagram together, we said, okay, in our case, we want to extend these diagrams or examples with the case when we have BMC as part of IPU, or if we reflected to Intel IPU, it's a IMC course versus ACC course. So, and if you look at diagrams that we submitted, that it's inside IPU, this yellow box of IPU, plus it has a fabric which connects XPU course with this XPU BMC. So in this case, what it allows us to do, it allows to do, first of all, in-band management, because we have this high-speed interfaces connected to both compute complexes, to cores and BMC. And plus, it provides us different services that we can split services between running on XPU cores and on XPU BMC cores. So I think this is the 2 major differences we want to show here. Plus, again, taking into account all our discussion about Redfish versus gRPC, what we did, we didn't put Redfish client, Redfish server here as the names for services we want to run. Instead of that, we used more generic, like remote manageability software or remote manageability client, remote manageability server. It means that it can run, depending on what software it's using, it can run gRPC or redfish.
I understand completely. So I think this is a good thing. The only question that I have, and this page that I'm sharing is from your pull request. So it shows the original diagram. This is in the left side and shows your additional diagram. So when I look at that, I see that those diagrams are almost exactly the same. True, there is a few differences like a switch fabric or PCI connectivity and stuff like that. But my question to the group and maybe to you, like, for me, those are the same use case. It doesn't really matter that IMC cores are on the board or inside the chip, right? So maybe it doesn't make any difference from that perspective. So I'm just wondering, this is a great work that you did. I'm just wondering if we can just combine these two diagrams instead of having two separate ones because they are so alike, and having a single diagram with components that are optional, for example, like switch fabric, Ethernet that we don't have here, or the PCI Express, and having a single diagram that represents the case when you do have BMC inside the DPU, whether on the board or inside the same chip. That's the only question that I have. Because those three diagrams before that represented 4 components: host CPU, platform BMC, ARM cores, and BMC. This one represented when BMC of the DPU is missing, and this one represented when the host is missing completely. So for me, this diagram and the first diagram are the same use case. Correct. The connectivity is a little bit different. The capabilities
I don't know. I'm not agreeing that it's a little bit different. I think the biggest difference that we have internal switch fabric, which connects these two components or two different compute complexes together.
I agree with you.
We don't have it here. And
I agree. So we can take the switch fabric and we can put it like we can remove the first diagram and we can remain only with your new diagram, and we can just say that the switch fabric is optional in case the NIC BMC and the ARM cores are on the same board but different chips, for example.
Well, what's the significance, or what's the difference if you have the switch fabric there or not, in terms of what you have to define for the DPU itself? Right. So is the switch fabric transparent to the rest of the stuff you have to define for this, or is it core, key, integral, however you want to say it, to it?
Well, the main difference from where I'm sitting is that the diagrams themselves do not differentiate between a physical port or an Ethernet interface. Like it doesn't have to be one-to-one tied to the port. So we had a kind of let's say this is the idea of roughly abstracting network interfaces presented to the XPU cores, the BMC. In our case, it's not necessarily a separate ASPID, right? It's not a separate chip. It's still additional cores, let's say, having access to the fabric as well. Sure.
Yeah, so your diagram is better, I think. But my question is, why would we leave the first diagram? Why wouldn't we replace the first diagram with your diagram and just mention that, for example, switch fabric is an optional, and then all the rest is exactly the same? No.
I'm not sure about whether do we want to have the connectivity, for example, the NCSI part optional, or do we want to keep those elements separate? Because, for example, in the case of NCSI, our, let's say, IMC, not BMC, terminates the NCSI as in this picture. The NCSI doesn't go to the part of the XPU cores, like in probably in the designs where there are only XPU cores. Sure. Or there is a separate ASPID chip, which I don't know whether it terminates the NCSI or the NCSI goes to. Oh yeah, NCSI also goes to DPU IPU, which was not accurate for the Intel IPU.
Yeah.
Yeah, I see where he's coming from, Boris, because NCSI could either be going to the ARM cores, or it could be going directly to the BMC, or in some case, yeah. So it's, where do you want to place that? Is that another optional component?
Yeah, I would have this on the same diagram. I would mention that it could be potentially that NCSI is going depending on the vendor. NCSI
Yeah.
can come from the platform BMC and terminate inside the ARM cores or terminate inside the IMC cores like NIC BMC. I would mention all of that as an optional because, again, if you look in those pictures and you look in all the diagrams, yes, there are 1, 2, 3 components that kind of here but not here, but all the rest looks very much the same for me. So I'm just wondering, again, not my decision, but I was wondering, wanted to bring this to discussion today, if it's a little bit too confusing to have very similar to use cases versus just remove this and have, combined diagram for this use case.
Yeah. Though, I mean, if you look at it a little more closely, where'd the annotation go? It's not enabled. So I²C, for example, comes from in different places you were just pointing. I mean, there's enough differences that it might be confusing to show them all on one, because you're going to have a whole bunch of conditionals on what's on the XPU BMC versus what's on the external NIC BMC, right? Because if you look in the upper left one, multiple things move between the upper left and the lower right.
But do you think that the left diagram, the first diagram, accurately represents any of the DPU vendors? Absolutely not. If you ask Vipin here on the call,
that's a different question. Yeah, gotcha. Yeah, good point.
Vipin here on the call, he will say we don't have a lot of components here, or the connectivity is completely different. It wasn't supposed to represent accurately any vendor. It's supposed to show all the possibilities that are there in the industry from the connectivity perspective, and each vendor will pick up, or you will pick up from that picture, like not all vendors have all the necessary connectivity available for you. This is what it's supposed to be initially.
Okay, gotcha.
NVIDIA is not represented by the first picture as well. Yes, they have separated NIC BMC, but a lot of components that we draw here are also inaccurate. So it wasn't supposed to be a one-to-one representative, because everybody can open the data sheet from the specific DPU vendor and see how it looks like.
Right. So I think, Boris, I would like to add one thing. I would say this is beyond vendor. I mean, a vendor could have 2 or 3 implementations depending on the cost points. So it is not even within a vendor. You could have variations depending on, well, why should I spare more on the piece of hardware if I want to bring down the cost? And there are reasons beyond beyond technical things that will lead to picking up one versus the other thing. And within a vendor, you could have variations too. So that's all I could say. I mean,
I agree. These diagrams, at least when I created those, supposed to show you all the different potential components that exist across all the DPU vendors that will help us to understand how the provisioning can potentially work, like what connectivity we can assume, we can't assume, and stuff like that.
Okay, so is there a baseline that's absolutely mandatory? And maybe that's the way to draw this, is say, here's the mandatory components in connectivity, and then here are the ones that are optional, and you can have any combination of those depending on the DPU. So, and is there a set of mandatory ones for us, if you're going to be an OPI compliant device?
I don't think no, there isn't anyone today. If we want, we can think about creating one. I also am not sure that we want to standardize the interfaces and the card, how the cards interact. I just use these diagrams to help myself and help others to understand, for example, how we do secure zero-touch provisioning, how we do boot sequencing, for example. If we start talking about boot sequencing, like how the components can actually interact with each other to actually exchange messages.
Yeah, and so I guess what I'm asking, it's a question, is there value in defining, here's the minimum set of interfaces the hardware has to support, and here's how they behave in terms of the rest of your provisioning stuff. And then here are the optional ones and what you get different or additional for, you know, for each optional one. Is that the way to define this, or is that overkill? And I'm open, I'm just asking. I'm
I
open
think
to,
it's an overkill. What we want to do is, for example, for boot sequencing, we want just to say, if you have these interfaces, this is what you should use. If you don't have those interfaces, those are alternatives that you can use. For example.
yeah, but
This kind of statement.
yeah, and so I'm gonna ask it one more time in a different way, just to be sure. Is there something that every DPU should have in terms of boot sequencing that makes everyone's life easier if they have it, that's already in common? In other words, it's
Yeah,
already Yeah.
even paraphrasing that, it's
Yeah.
what is the what? Yeah, we have the aspects of standardization, but if for each aspect we're going standardized, we have 5 different ways suiting just one device. It kind of kills the idea of standardization.
I agree completely. But first we need to find the methods how to do it, right? We jumping into the second pull request on boot sequencing, but yeah, for example, for boot sequencing, we don't have a clear solution how we do the sequencing yet. So we cannot really say which interface we're going to use to do so.
So the ultimate purpose of this pull request is to define the possible set of interfaces as we know them now, the maximum set of possible interfaces, and what each interface can and can't do. And then it's like,
No, Joe, the pull request is just adding a new diagram for Intel. The page already existed. The three pages existed. The pull request is only adding new diagram, which is Intel oriented, which has BMC inside the DPU itself as not as a separate chip on the board, but inside the
embedded controller with fabric which connects these 2 compute complexes.
Yeah, thank you, Andrew. So this is a pull request, just add another diagram. And
okay,
my question was, can we just fold this diagram or fold the first one into this? Because for me, those are very similar use cases, and we can put all the goodness, Andre, that you put here, right? Everything here is gold, right? The switch fabric, the abstraction of the network interfaces, the additional PCI Express connectivity, the language changes, all that you did here is absolutely excellent. I'm just saying we can just use this diagram and fold them together with the first one. That's all.
Could we also abstract the Ethernet interface and ports somehow? I don't know whether we wanted to have effectively what we had is we have ETH on both. For example, in the XPU in the diagram that Intel provide, the ETH interfaces on the XPU cores. Whether do we want to write somehow that there are like external ports and some of those are just Ethernet interfaces that are not bound by the let's say the physical interface. Let's say it doesn't have to be RMII, right? It might be PCI.
Yeah, if you think it's important, for sure, why not? I don't mind either way. I see the value having very abstractive description that not every interface have to be a physical one. I also see the value to actually show that sometimes you can separate networks to having a separate connection there. So I'm flexible. Either way, it's fine.
Yeah, because in this picture, we used ETH inside cores, but actually it's just a virtual ports. We can have multiple interfaces.
Yeah, because you have a switch. Yeah, I understand.
Yeah, that's for Intel, but we've also left the /fabric, meaning, for example, it might also be like some kind of Ethernet switch, even if someone was creative enough, right, and had physical interfaces going there.
For this specific area on your diagram, I would leave it like this: switch and fabric. You have your Ethernet ports. You have this. Like your diagram is perfect. Is much better from this perspective. Just mention that the switch fabric is optional. That's maybe with the color coding or dotted line or whatever.
Well, for now, kind of several elements of these are optional.
Yeah, I agree.
Mm.
Well, that should be noted. I mean, for sure, the optional, again, mandatory versus optional. And if everything is optional, then, you know, maybe
We're not
that's,
standardizing anything if everything is optional.
yeah, well, that's the,
We are not standardizing on the hardware interfaces, right? We're trying to standardize on protocols and methods mostly, right?
but they have to use the hardware interfaces. So the question is there a minimum expected? We're not going to define the details of how that hardware interface is built for sure. I agree with that.
Yeah, true. But if you're defining, for example, that SM bus messages are used, just for example, right? SM bus is used for boot sequencing. I don't care if it runs on I2C or over PCI Express.
Okay, that's a fair statement.
But there can also be some confusion added to it because you've got different interfaces that can be in the BMC, and then similarly, depending upon the architecture, you can have them going into the XPU cores. I mean, there's somewhere you got to have some sort of statement or document or explanation that's outlining where the different things can be, how they can be used in different situations. And then you're going to have your common things, which you want to try to standardize on, which is really the protocols.
I agree, but I think that we need to drive it from the solution. We solve how the boot sequencing works. Then we identify which are the must components that participate in that solution.
Oh,
and
yeah,
then we standardize on that.
Yeah, no, don't have an issue with that. It's just that just make sure we don't add a bunch of confusion with the diagrams with people, and make sure that we have explanations of, okay, this is what this interface is and where it can live. It's where it can live that can cause confusion if we put it in one place versus another.
Yeah. Okay. So Andre, again, I'll let you think this through. If you don't want to change it, that's also fine. I just wanted to bring it to the discussion today. Now I think I understand better where you come from, and I think that you and Masay, you understand a little bit better from where I come from when I originally created those diagrams. Look at it again. If you feel that it's okay to merge it into a single diagram, or even remove the old one and just leave the Intel one, that's fine by me.
Yeah, to be honest, I prefer to keep it separate because at the moment it creates a different use. I mean, not different, but I think some use cases can be implemented differently if we have this embedded BMC. So I'm not sure that, okay, if we merge it into one picture with all those optional components, it probably will eventually create some confusion, what is optional and what is not. And then going forward, my feeling is that we eventually will have to go back and put them as a separate diagrams.
Or as an additional, let's say, note, we could use the first diagram that's currently uploaded as the case where the BMC is completely separate, like, and even the BMC might be an optional case, right? For on the board.
Mm-hmm.
I'm thinking whatever I've read in the Bluefield 3 datasheet, it contains a BMC. If I understand correctly, it might be an optional component or a completely separate added generationally. So if that's the case, the connectivity will be different, obviously. So it might even be more accurate in this case to have the connectivity clearly outlined in a separate diagram.
I agree, but what is the difference between BMC is present versus BMC is not present? That I understand. But if BMC is present, what difference does it make if it's a separate chip or embedded inside a chip? You can, even with two-chip solution, you can have high bandwidth fabric. You can put a switch on the DPU card, on the board itself, have PCI Express connected to that. So you can have all of those independent, whether there was a two-chip solution or the embedded one. This is why I fail to understand the difference.
We are terminating NCSI in a different manner. At minimum, that's one thing, and we can obviously start putting optional lines here and there. I just don't want it to become, let's say, a monster at some point. It will be hard to read, but you know, we'll see in time probably whether it's going to be ugly or not.
Yeah, and in addition to that, I think what is not shown on this diagram, we provided with Maciej, and actually it is important, but we don't know how to show it. It's okay, we call it BMC, but by nature, in addition to BMC, it provides additional functionality and it's infrastructure manageability controller, so it can handle resources as well of IPU. It's not only BMC as such. So, and it could lead to differences in boot processing and updates and so on. And it's why I think we added this. It's why we added this in band, for example, here, because for us in band is natural because we have this fabric and we can our boot sequence can be like implemented in a different ways because it's a one chip.
Again, I'm fine either way. I prefer to merge it. If you don't, that's your decision. That's fine. But if we keep it separate, we need to document really well on the diagram, for example, like how it's different from the first one. Because just looking into that without having this meeting and this discussion, it was really hard to identify what the differences are. So either way, we need to either list or color code and emphasize what the difference between the two diagrams. It was really hard just looking into two pictures to understand the difference. So we need to document either way. If anybody else from the group has an opinion, whether we need to merge it or keep it separate, please, feel free to jump into the discussion.
I think if it stays separate, the documentation you described, Boris, is critical. So it has to be described so that you can tell what's important from compared to the generic diagram. And that'll help remove confusion, I believe. So again, if Intel feels it should say separate, again, I don't have an issue either, but I think it needs written descriptions of to support the diagram with notations on the diagram to further enumerate why certain things are important. And again, that'll explain, then it should be obvious to people why it's drawn separately. Does that make sense?
Yeah, okay, Boris, I think we have an idea. So leave it with us. We'll go through it internally and see how we can make it more clear and what documentation we can provide with this diagram. So and then we'll create a new pull request, okay?
Yeah, thanks. And others, if you don't want to speak now, always feel free to go on GitHub and comment on the pull request. So this is all collaborative work.
And I assume there's no significance to the kind of naming differences of things, right? That's just an artifact that we have a bunch of names that are kind of synonyms for each other, correct? And so just don't worry about those, right?
Mm-hmm.
Okay. I'm fine.
Yeah, I think why we put this XPU on this diagram, because it's first of all it's only 3 letters instead of DPU/IPU. I think maybe we can agree and use this term as a common term.
No, I just wanted to make. I don't care much about terminology other than to know that there isn't any meaning intended between the different terminology, right? You don't mean something different. It's just those are the letters you pick to represent it, which is fine.
Yeah, at the level of connectors, maybe, but it might vary at the level of what's this device supposed to do in terms of the overall platform, right? It might be an offload machine, but it also might be a completely isolated, separately managed entity, right?
Yeah, that's
but
all.
I remind you, this is hardware components diagram, right?
Mm-hmm.
It shouldn't supposed to be representing the intent.
I began with at the level of hardware, it doesn't matter, or it shouldn't.
Okay.
Okay, let's move on. We have a few more topics to discuss today. So again, pull request is on Intel, and go ahead and comment on that. Another pull request I want to show you is on boot sequencing. So Ted presented this pull request, I think, like a month ago on January 10th. So yeah. And we have 0 comments on this. So I want to bring this to the kind of open discussion. People didn't read it, didn't understand it, read it, didn't think it's useful, we should close it, or people have a different intention, how we move the boot sequencing forward. I'll put it in the chat. I'll stop sharing so I can see the people reactions and instead. Like I would least I would like to understand if people just didn't have enough time to read it or think it's not an interesting topic. I want to understand where to take this work group and this item. Is it clear what we're trying to achieve in the boot sequencing?
Boris, was there any follow-up discussion? I haven't checked, but I've opened this issue on the in GitHub, copying the comment from the comment section from the last time. I don't know whether there has been any traction there.
Yeah, again, excellent. Thank you for reminding. No comments, nothing. So want to understand if people want to volunteer to take this work, for example, on CRS. Let me copy the issue again so people can have it. I see Vipin, thank you. We will comment it by today. So from Marvell perspective, Reza, welcome from HPE. Like on boot sequencing, you want to take something and maybe one of the topics and develop it a little bit.
Yeah, I can dig into it some more. I think this is very important work for us to collaborate on.
Excellent, Reza. So action item on you, I'm writing to also comment on this pull request and the issue from the Slack.
Yes, I will.
Excellent. Excellent. We can take small steps, right? If people think that CRS is a good way to solve problem, then we can, bring it to discussion, work together, and draft a proposal. But we need somehow to make it happen. Otherwise, we just talk in between week and nothing happens. I would also like Masay and Andre from Intel perspective, like what is your view on the boot sequencing? I also didn't see a lot of comments, like specifically on the proposals. If you have a different view, having the embedded IMC, maybe you propose a different boot sequencing solution. So I'd like to understand from Intel perspective, what is a proposal as well?
Well, the issue is still relevant, meaning that, if we're doing NVMe over Fabric boot, NVMe boot from the host, which requires NVMe over Fabric TCP connectivity established by the XPU cores, then definitely that's relevant. The host needs to get that information. As for the sequence on our side, the XPU BMC comes first and the XPU cores, but so finally at the end of the day, XPU cores have to come up, prepare the services, etc. So it's still relevant at that point. So it's extra step, but I think the PCI or others or the other proposed solutions, yeah, it's still within the option space.
Okay, so no preference, both of the options. I think we need to decide whether we're doing in-band or out-of-band. Because for in-band, I don't think we have a lot of different options except for something on PCI Express, whether it's CSR or something else. On the out-of-band, we have quite a lot of options, and this is where I think the diagrams of the hardware components can actually help us to understand whether we can use I2C or NCSI or something else. And if we do that, which protocols are we using? Are we using SMBus, MCTP? We're using PLDMs. But I think the first order is kind of try to define in-band PCI Express or out-of-band.
It's more of a whether the IPU or the XPU and the host should synchronize themselves, or should an additional entity be involved. Then it's a matter of interface. It's the hierarchy that's relevant, not the interface itself.
By other entity, you mean the BMC, the MC?
Yeah, but by the host BMC, for example, right? Should it be the coordinator of the boot or not? It doesn't have to. If you involve PCI, it doesn't have to.
Mhm. But still, what you're saying is, for example, for IPUs, right? So what you're saying is IMC controls both of the booting of the ARM cores and the host itself, or still you think that host boots independently?
No. I mean, BMC's role at minimum, being IPUs or XPUs in total, being PCI cards, is that at minimum they control the power and the thermals. So naturally, BMC will come first. Then it might start the host plus the XPU, right? But at that point, IPU, it's probably not required for the XPU to report to the BMC, for the BMC to then relay that information to the host and release the host for further booting. If PCI is in place, you don't have to do that triangle.
Yes, if you're using PCI, but then somebody raised the question about if you're using the CSR, for example, method, right?
Yeah, it's still open. It's still open at whether the specification allows us to do so, especially for a longer period of time. There is also the open, obviously, but it's probably going to be there's additional work that will be required on the EDK2 in order to support such a thing. Because at that point, I don't think that current EDK2s even respects CRS in the first place. So
I agree.
Yep.
Those are 2 points. First of all, is a timeout. I think that again, I cannot speak for HP, but I know that Dell looked in it and changed the timeouts for CRS in the Dell BIOS. I'm not sure what HP is doing in that space. Maybe Reza can help us.
we could make it BIOS or somehow configurable for the sake of enablement.
Exactly. And the second is a EDK, like you mentioned, whether we have support for that or not. How important is EDK, Masay?
Sorry?
How important EDK is from Intel perspective?
I mean, if we're going PCI route, then it's vital.
Okay.
Meaning that without support in the platform for respecting CRS, there is not going to be a synchronization, right?
Okay.
I'm not saying we are going that route. It's still an open.
Yeah, I'm just looking maybe for a way for us to move forward. Like Reza said, he's going to help us from HP side. Reza, you think this is very important? I do as well. So how can we move forward? Will you bring some kind of proposal to us, or?
Yeah, I can speak to it briefly. So the CRS method, there's some challenges with that in terms of timeout and how long a processor can actually wait. And there are some mechanisms for extending that timeout, but there are challenges with that as well. One of the things that we're considering is that there should be a hardware function zero that's always available, that's not dependent on a software PCIe manager running on the ARM cores. And that hardware would have perhaps a class code in the function zero that indicates this card needs to be treated differently, and maybe you wait for a timeout. But that
But Reza, at that point, if there is if a mandate for such function would be there, nothing stops us to actually implement an option ROM instead of extending EDK2 on all the other platforms, which would actually make a lot of sense because, for example, if we take older hardware, older servers, we wouldn't need to add additional quirks to those. We just put those. The card can synchronize itself. I know there might be some problems with the timeout, obviously, but it might be possibly configurable. But if we had significant, let's say, guarantee that the first drive, the driver on the PF0 would come first, just to check whether all the other functions can be, let's say, relatively enumerated, and then further option ROMs or further, I don't know, integrated drivers for NVMe in the UEFI firmware can be bound to the next PF, then sure, it would be even easier.
yes,
We wouldn't have to look at the CRS PCI spec in the first place, aside from the guarantee on the UEFI side to execute the option ROMs and execute enumeration in an ordered manner.
well, yeah, I think we're on the same path here. In that there's all of the functions don't have to be available at the start. It's only the function 0, the physical function 0 needs to be available, and that will have some status in it that tells when the rest of the functions are ready. Now, the challenge we face today is that the DPU or the Smart IO doesn't respond at all right after reset, or sometimes there's I gotta be careful what I say here. The behavior is not predictable. That's a challenge, and so what we're looking for is some predictable behavior, that some hardware function, even with minimum functionality, some function 0, even with minimum capability, is available to at least accept the config cycles and not put us into very long retries, right? Because the processors can't handle the long retries.
But let's say if I go with your idea, Reza, just to make sure I understand. And this physical function 0 is present immediately, that's fine, and it's present some kind of new class. Still, we need to change all the BIOSes to behave on this and wait for the status that it reports in order to continue, right?
If it presented option ROM instead, you wouldn't have to do that.
But I think
we need a mechanism.
How do we get all of the DPU vendors to behave in a similar manner?
I understand. That's an excellent question. I just want to ask the clarification just to make sure that I understand. Let's say we have that, to Masay's point, we need BIOS to actually read the status and be in a wait loop until the status changes. So that requires a change in all the BIOSes of the server.
But if the option ROM is implementing that loop.
Okay, I understand. Which is what you send during the boot.
Yeah, I mean the UEFI firmware definitely executes the option ROM, right? We can definitely wait for a given timeout. It might be configurable even if we want to post such a thing, and it would be it would be definitely rational. We don't want to hold the hostage. Sorry for the pun.
So that would be vendor implementation in that case.
Yeah, in that case, yeah.
I'm sorry, I don't follow the context there with the option ROM.
Yeah, sure. So if you have PF0 and PF0 will be enumerated, I'm assuming that the option ROM tied to that physical function would be executed. if it would be executed and physical function 0 can read some arbitrary register or has any other means to interface with the card, I don't know if it has to interface with its firmware, or there is some hardware thing, but something that is non-standard, that's currently non-standard, meaning non-standard and not implemented in current firmware of the platforms, meaning hosts, then the option ROM can abstract whatever access is required to the adapter in order to establish whether the synchronization is finished or not, or necessary initialization of XPU cores and then services in there, right?
And that option ROM will abstract away the differences from vendor to vendor.
Yeah, I would say so, but it would require certain, let's say, investigation into guarantees. For example, you don't want the second, like, let's say, if you're exposing on an adapter a couple of PFs, right? And the drivers for the PF1 and PF2 come up first, or are bound first to the other device instead of the first one, then this idea will not work, right? Because it assumes that the first function is handled first.
Yes.
Mm-hmm. So if we have that guarantee, I could check it. It would take a while, but I could check that in EDK2. For UEFI, obviously, I cannot. I will not speak for BIOS. For legacy ones, yeah, there might be some guarantees like that. So it would be good to see that in UEFI spec and EDK2 implementation.
I will check with our BIOS team.
Mm-hmm. Yeah, let's do it independently. If we have different view on that, it would be good to argue.
But then it all depends also on this physical function 0 to be always present, right? Which we don't have today from all the DPU vendors yet.
Okay, meaning that it will not. So the device will not present any functions if the XPU cores are not up.
It will just try the Reza. What is it doing? The retries currently?
Sorry, I didn't follow.
You need to reboot. Like what you said that sometimes when you reboot the card, the DPU, that the PCI Express config space is completely messed up, or
right, it's not available. It doesn't follow the PCIe spec in terms of, it should be it should respond to config cycles with 2 seconds after reset was released, so that it's a PCIe violation until the PCIe managers run, which is running on the ARM core, right? That the PCIe manager is a piece of software that runs on the ARM core.
I would guess depending on the vendor, but yeah.
Depending on the vendor, yes, depending on the vendor. This is the challenge, because some vendors may have that up and running sooner than others.
So if we're not taking that route, just to make sure we cover all the options, I think that the other possibility is to have out-of-band management to make notifications when the DPU finish boot, at least the initial functionality, so we can release.
And there again, we also have the uniqueness challenge. It's difficult to mandate in the out of band. It's difficult to mandate that they all use the same access mechanisms. Now, bearing in mind that right after reset, the software to do abstraction for like Redfish and or any other mechanism is just not up and running yet.
Well, I'm
I
not
understand.
sure.
So the idea here, the idea here is that CPU will be halted until the DPU will be able to send a notification to release from reset, from halt. And we can standardize on the protocol, right? For example, I don't know, from the top of my mind.
Okay, so there are two things that are happening here. After reset after reset is released, okay, before that, it says power is applied to the server and the BMC comes up. The x86 host is held in reset. The DPU is not powered, right? The DPU is not powered. The user pushes the button, power is applied. x86 host is held in reset. DPU starts to power up. Few seconds.
Yeah.
Right. When
DPU
the
thinks he
BMC
booted enough, he will
right.
notify the BMC.
Right. So BIOS starts to run on the x86 host, and it's walking the PCIe buses looking for which devices are out there.
Yep.
And so this is where we run into the challenge, because some devices don't necessarily behave predictably.
But at that time, I would guess that DPU is booted enough so he can assure you that all the PCI Expresses are configured, all the devices are up and running, and you can rely on that if notification was sent to release from reset.
Well, at that point, yeah, the platform firmware, meaning the host firmware, UEFI firmware, would have to wait until wait for the PCI enumeration before the notification comes up. So the whole PCI enumeration stage awaits.
Yes.
Which is basically a requirement on the platform to support such a thing. Meaning that if we were to run new hardware on old, or new hardware meaning new XPUs on old platforms or currently existing ones, it will be impossible. It would, or at minimum, it would require firmware updates.
Yeah, there's a race condition.
Yeah, go ahead. Go ahead, Reza.
Yeah, there's a race condition between BIOS discovering or doing the discovery and the DPU having enough cognizance to respond to PCIe cycles.
Yeah, but if host CPU is held in reset until DPU notifies the BMC that it's booted enough and the reset can be released,
that's the out of band.
That's the out of band, exactly. Yeah. And if talking about out of band, we can talk about a lot of protocols, SMBIOS, MCTP, PLDMs, whatever we can do, and whatever physical interfaces we have, and CSI, how we can notify the out of band between those.
Well, the piece that I think we have a race condition there as well, because if BMC starts to pull the device and the device is not answering because it's just not ready yet, the DPU is just still not ready yet, it may not have enough, it may not have booted far enough where it can respond to those other protocols.
Maybe it's a push and not a pull. Maybe a DPU pushes notification to the BMC that I'm ready. Or
so the BMC will have to wait for a timeout also.
Exactly. The timeout shifts. The timeout's now in BMC, and after that timeout, if notification is not received, BMC is releasing from reset and boots without the DPU, and waits for DPU notification otherwise until timeout, like a keep alive or something like that. That, again, not saying this is the best way to implement it, but just giving another opportunity or another option.
Well, a workaround for PCI violations, right?
Right. Yeah.
Okay. So we're out of time today, but I think this is an excellent discussion. Do everybody feel that this is the right discussion to have next time to start with and continue?
I agree.
Yes.
Defining the set of boot sequences and their considerations for all the DPUs that are actually out there and what comes next is critical.
So Reza and Masei, if I can put an action item on you to just maybe come up with one slide or few sentences on of those options: in band, out of band. In band, I guess only PCI Express versus out of band, pros, cons, and maybe challenges that we have now. And then we can, have something in front of us to work with. So
now I can try to do the research on the EDK2 side of things, meaning whether it's What kind of guarantees are there?
And Reza said he'll check with BIOS team.
Mhm.
Okay, we can exchange ideas on Slack as well. I just remind you, don't have to wait for next week. Thank you.
Very good. Thanks, everyone. Bye-bye.
Yeah, thanks.
Thanks.
Take care. Bye.